Hello, Brett Ethridge here, founder of Dominate the GMAT, and I'd like to talk to you about the importance of using logic and common sense on the GMAT to get more right answers, but also to give you a little bit more freedom on the GMAT. And here's what I mean by that. You're probably familiar with the famous American patriot Thomas Paine, who wrote the famous book or pamphlet called Common Sense. And what was its purpose? Right? Its purpose was to hopefully produce more freedom and independence, liberty for the American colonists, and it did exactly that. Now, at the risk of being too corny, I would suggest to you that common sense can provide really the same type of freedom for you on the GMAT. And we're going to take a look at an example here in a second, but here's what I mean by that. You know, so many of my students, especially my international students, come to the GMAT with the mindset that you have to actually solve every question, and you've got to do it the textbook way, right? And a lot of, especially my Eastern European students or students from Asia, you know, they really feel like they need to answer it exactly like their high school teacher may have taught them how to do it. But what's your objective? Right? Your objective is to get right answers. And if you've watched any of my other free videos, you know that I'm really a big advocate for results-oriented approaches on the GMAT. And using logic and common sense is a great way to sometimes be able to arrive at a right answer, or certainly eliminate several, if not three, maybe even four clearly wrong answers, just using a little bit of common sense. So kind of with that as background, let's take a look at this problem. All right, so the problem that you see on your screen, and go ahead and take a second to try it, press pause, and see how you do, and then we'll come back and talk about it together. All right, how'd you do? All right, so some of you, let's be honest, you can just answer this question in about 20 seconds. It's not hard for you. Hold on, I'm going to go ahead and change my pen color here. But what if you don't know how to do it, right? What do? I mean, you might still be staring at this question, having no idea what to do or how to do it. Well, what if we use a little common sense, right? What's hard about this problem? Well, what's hard about the problem is that this is kind of tipped at an angle, right? And we know that we need to find the area, and so we always want to start on our scratch paper by being very clear about what we're trying to solve for, where the area is 1/2 base times height. So that limits our focus, right? We're really just looking to find two things. If we can find the base and we can find the height, we can solve this thing. But you might be thinking, well, what in the heck is the base? What in the heck is the height? I don't know how to do this, right? Is this, by the way, is this a right angle down here? I don't know, right? So let's talk about common sense. What if, right? What if this thing were slightly tipped down? Does this make sense? Can we ballpark it, right? What if instead of being tipped the way it is, it were tipped kind of straight on its head, and the base of this thing kind of looks like that, right? Maybe the triangle kind of looks like this instead. Would that make it a little bit easier? Yeah, because now this is clearly the base, although it's like the top, but it's still the base, because if you think about it flipped upside down. We drop an altitude, that becomes the height, right? Could we now solve that? Well, yeah, obviously, because the base now kind of goes from here to here, and this has already been labeled at 7, and we can count 7 ticks over, so the base is 7, right? About. The height, I don't know. I mean, you could either say the height's 3 or 4, right? So maybe you say it's 4, so that's 28, right? Divided by 2 would equal 14. Okay, maybe. If you said the base is 4, maybe you think the base is a little bit further down here, like at 3, or maybe it's 3.5, something like that. Even if it's 3, then you have 7 times 3 is 21 divided by 2, right? Divided by 2 is like 10.5. But here's the point. Just using a little bit of common sense, we have a pretty good idea of what the area is. Does that make sense? And so it's somewhere on the high end between probably 14 and on the low end like 10.5. And what do we know about the answer choices? They're always in ascending or descending order. And so certainly 14 is probably too big, or maybe it's in the ballpark, but that means 10 root 2 is too big. That means 16 is too big. That means 25 is too big, right? And so a little bit of common sense can help you get there. And in fact, obviously 14 would be too big. If somebody put a gun to my head and I were just eyeballing it, I'd probably say the answer is A. Right? Now, here's another way to look at it, another kind of logic or common sense type of a way. Right? One of the things that a lot of students wonder is this a right angle? Who cares? And here's what I mean by that. Remember on the GMAT, on problem solving, figures are assumed drawn to scale unless otherwise indicated, right? Does this look like it's drawn to scale? Yeah, to me it does. It looks like these are evenly spaced, right? It looks like these are evenly spaced, so that means that's probably really 1. Over here, this is probably really 7, right? It looks like it's drawn to scale. And does that look like a right angle? Well, it's pretty close to me, right? And so we can still proceed as if it is. Because what if we're wrong? What if instead of being 90 degrees, it's like 88 degrees? Close enough. What if here's the point. It looks close enough that we can work with that. And we do know for sure that this is a right angle. So what do we know? That this is 3, this is 4, right? So for this triangle, we'll just kind of call this A, B, C. Well, that's already P, so my apologies. That's P and that's Q. So we'll call it QBP, right? That's a 3, 4. What's one of our common right triangles we need to know? 5 right triangle. So regardless of whether this is a right angle or not, we know for sure that the length QP is 5. And likewise over here, we can kind of drop an altitude down. We know for sure that that creates a right angle. And we know for sure, at the very least, from 4 to 7 is 3, up 4, right? And it's a right angle, so 3, 4, 5. So there you have it, 5, 5. Could we now find the length of that? Well, if we assume it's a right angle, we could, and there you have it. So either way, and by the way, at that point, if those are the same, that means these are 45-degree angles. And what do we know about the hypotenuse? It would be 5 root 2, right? And so in that case, actually that's irrelevant. We wouldn't even need that because if this is a right angle, then this becomes the base, this becomes the height. And base times height, 5 times 5 is 25. Half of that is 12.5. And there you go, right? So if you had to eyeball it, you could absolutely come up with answer choice A as well. And there you have it. So a little bit of common sense, a little bit of logic, at the very least, look, we got rid of 4 answer choices straight away just by kind of using a little bit of logic and common sense. We also used kind of the eyeballing technique of saying, hey, that looks like a right angle. I'm just going to kind of go with it, assuming that it is, and know that the area is about 1/2, 5 times 5, or 12.5, so you can get it that way. And then this is just purely from a teaching standpoint. While I have you here, how would you know for sure, by the way, that that's a right angle, right? They didn't label it as such. How might you know? Well, remember that a right angle or perpendicular angles are created if the slopes are opposite inverses of each other. And so here's what I mean by that. What is the slope of line QP? Rise over run, right? 3 over 4. So the slope here, M equals 3 over 4, except it's a negative sloping line, so it's negative 3/4, right? What's the slope of this line? PR. Well, rise over run, positive, in this case, it's a positive sloping angle, 4/3. Sure enough, are 4/3 and negative 3/4 opposite inverses? Absolutely. And so that's another way just to confirm in your own mind that in fact that is a right angle. But you didn't have to do that much work. Like I said, some of you guys probably figured that out and you got this question right in about 20 seconds. If you were one of those people who looked at it and just weren't quite sure what to do, hopefully this whole idea of common sense really makes sense to you. And I hope you find that liberating. I hope you find a lot of freedom in that. You don't always have to do GMAT questions by the book. Your job is to get right answers. And as you see in this question, it certainly is a question that you can easily get right, even if you didn't know how to do the math. Even if you didn't know how to do the math, you certainly would need to know the area formula to at least have a chance at it. But nevertheless, that's a way to proceed. So take this to the bank, enjoy it, and may it serve you well and enable you to go out and dominate the GMAT.